Okay, so let's start with today's class. Okay, so we started with the longest common subsequence, which is a type of dynamic programming problem. It's an example of dynamic programming. So first of all, we have to understand what a sequence is and what we mean by subsequence. Subsequence will be a set of elements of a sequence that appear in another sequence in order. So they need not be continuous. So it's not a substring, it is a subsequence. So what to understand and solve this problem, what we are doing is we are trying to first define the prefix of a sequence. Okay. So given two sequences, we are naming the sequence element wise x1, x2, x3, so on up to xm. M is the length of sequence x, n is the length of sequence y. So given a sequence, we first define the ith prefix of a sequence. So I'll come to this in a while. So ith prefix of a sequence is the elements of the sequence up to the ith element. Okay. So what we do in case of longest common subsequence, what I told you yesterday is that brute force would mean we find the subsets or all possible combinations of the elements of this sequence and then try to match the subsets of x with all the subsets of y and then see which subset which matches is the longest one. So that will be brute force and that will take around n into 2 to the power m running time. Okay, this we discussed yesterday. So what we do is to break the subsequence into smaller problem. What will be a smaller problem in terms of matching two strings? So if the string size is less, we can easily match them. So if there is a string or a sequence of one element and another one is also a sequence of one element, it's easy to match. So we break down the matching problem of two sequences of length m and n to one lesser length. And we do it by matching the last element and not the first element, because that way then you will miss out. When we do it the other way around, you will see that we do not miss out on the subsequence lengths. Okay. So when we, for example, here, when you match E and E, you are left with X with a length of 3 and Y with a length of 2. Okay. So there are three possibilities. When you try to match the last element, either it matches or it does not match. Okay. Or let's say the length is 0. So that, let's come here. Okay, so if your last one matches, then your xi is equal to yj. So I and j are the lengths of the sequence. Then your problem gets reduced, like I said, to finding the longest common subsequence between this, if it matches. So that means the longest common subsequence problem of this plus one match you have already found, right? If it does not match, then obviously let's go to an example where it does not match. For example, here it does not match, so G and D does not match. Okay, but you'll see D matches with this. So if I break down my problem into x3 and y3 and x4 and y2. So in this case, in the first case, I match this with this now. So I drop out the fourth element of x. And in the second case, I drop out the, I match, I take x4 and I take y2. So I take only, in the second case, sorry, in the second case, I take x4 and this. Okay, so these are the two possibilities if the last element does not match. So but I have to, these are the two options and I have to find the longest common subsequence. So whatever answer this gives me and whatever answer this gives me, I'll compare them and find the max. That's what I'm doing here. Okay. So to find the longest common subsequence of x and y, we need to find the longest common subsequence between x and y n minus 1 or xm minus 1 and y in case the last element does not match. And we have to see which one of the two will give us the maximum value. Okay. And you'll see that subproblems will share subproblems. So basically, this is what our problem boils down to. What we are storing in the array is the length of the longest common subsequence of two sequences given of lengths I and j. So if I and j are 0, that means we do not have anything to match. So there is no longest common subsequence if either one of the two are 0. Okay, so we have 0 length. So what we will be storing is the length of the longest common subsequence. If the last elements match, then we take that as an option, as in we take that length, the match as 1, that is this one here, and then our problem gets reduced to I minus 1 and j minus 1. So now we have to find the longest common subsequence between xi minus 1 and j yj minus 1. In case they do not match, so then the condition comes that we, in this case, we drop one element of y, the one that did not match, and in this case we drop one element of x that did not match, and then c, by dropping that in these two ways, one from x and one from y, we generate two subproblems, and then we find which subproblem gives us the maximum of the two. So before we move on with the presentation and code, I want you to first go through the problem. I just, are you able to see this handwritten PDF? No?
No, ma'am.
Okay. Now,
Yes,
Yes,
ma'am.
ma'am.
so here is an example of two sequences. X is the word award and Y is the sequence WDRA. Okay, the length of X is 5 and the length of Y is 4. Now we have to find the longest common subsequence. So if you look at it, if you see in order, after W you get A, and the maximum length in sequence that you can find which is common is 2 only. So now that is the problem that we have to do by using the formula that is given to us. So again, writing the formula here. If your last element matches, for example, if your last element matches here, then we will use, if it matches, then we use this. If it doesn't match, then we will use this formula. Okay, now the problem that we are looking for is to find the longest common subsequence between x, which is length of 5, and y, which is length of 4. So C54 should have our answer. So we are doing a dynamic programming problem. We will have to solve in a bottom-up approach, but I'm just writing it down in the top to bottom approach, like how we usually write recursive problems. If you see here, this is written in top to bottom, but we do the calculation in the reverse order. So based on this formula, I have written what will be C54. So C54 will be 0 if one of the two lengths are 0, which is not the case in this case. C54 will be equal to C43 plus 1 in case the last element matches, and in case the last element does not match, it will be maximum of C53 and C, or C44. Okay, now I've just drawn a few boxes of the 2D arrays C. Okay, this is your C, and this is just the rightmost bottom corner of your 2D array. This, I've just named the columns. This 5 3 is row 5, and column 3 5 4. So your 5 4 here either depends on 4 3, which is here, or it depends on 5 3 or 4 4, which is here. 4 4 and 5 3. So your 5 4, the answer to this can either come from 4 3 or 5 3 or 4 4. So that means if when you are doing this calculation of this 2D array here, this box is dependent on these three boxes. Any such value that you're trying to find will be dependent on these three boxes. The answer can come from any of the three. So when we are doing the calculation in a bottom up fashion, we have to make sure that this row is calculated before the second row, and in the row also you have to do a horizontal calculation, because you need this one here, you need this box here. Okay, that comes before the colored box here, so that also needs to be calculated. So every row has to be calculated left to right, and you have to calculate row by row. Okay, so your value, the C value on the left is dependent on three previous C values on the right, and that's why we will do our calculation row by row, so that all the values are ready. And these are values, these are sub problems that can arise in any other equation as well, so we should be ready with the previous values before we calculate the higher value. So just like in matrix multiplication we do diagonal calculation, in knapsack we do row by row, this is also row by row. Okay, so the arrows, this is the 2D array. The arrows that you see, this tells you where the value came from. Okay, we'll discuss that in a while. So when you draw the 2D array for this, it's very easy to actually fill this up. So first we are going to do row number 1. Row 0 will be 0, because when the length is 0, the first row and the first column is 0. Now when you are talking of C11, okay, you just have the prefix of x, xi, which is 1, and you have prefix of y, yi, which is 1. So you're basically comparing a with w. So obviously a and w, they do not match, so the answer is 0. A and D do not match, so the answer is 0. A and R do not match, answer is 0. A and A matches, so the answer is 1. Okay, very simple here, since this is only matching one element with one element. Now, when we are talking of this is your basically x2, y1, and then y2, and then y3, and so on, y4. So your x2 is AW, and the first element is W. So when you match AW with W, okay, W and W matches, so then you are still left with the sub problem. Okay, let me go down here. So this is C1, this is the first row calculation which we already did. It's pretty simple. C21, this is what we are looking at. Since there is a match AW and W, you are comparing AW and you have W. So the last element matches, that one is here. And then you are left with what? C10. After that, once you eliminate this W, you are left with only A. So C1 and 0. And when one of the two is 0, you get a 0. So your final answer is 1. Okay. So when we take two elements from X and two elements from Y, here, if you look up, AW and WD. So we start matching from the last one. It does not match. So obviously, when it does not match, we have the two sub problems and we find the maximum of the two, 2 1 and 1 2. So 2 1 and 1 2, if you look here, 2 1 is 1 and 1 2 is 0. So out of the two, 2 1 is 1. So 2 1 is 1 and 1 2 is 0. So the answer, this one here, it is dependent on the previous one on the left hand side. So that's why the arrow arrow of this goes left, because this is your 2 2, right? This circled one is 2 2. Now if you look here, 2 2, it can be either max of C2 1 or 1 2. Okay, let's go back. 2 1 is this and 1 2 is this. Obviously 2 1 is greater, so we will 1 will be our answer. So, and this green arrow on the left shows here, it shows that the answer came from 2 1. Okay, that's what I have underlined here. The answer has come from 2 1, and that's why in the matrix you will see left arrow. So left arrow means out of that, the answer comes from ij minus 1. If you see here, if this one is selected, so the answer comes from I minus 1j. So these are the, so if this is I and j, this is I minus 1j. This one here is ij minus 1. And this one here is I minus 1 and j minus 1. So this will be the case of match. Left and right will be the case of this maximum. So I'll show you in the presentation as well, this box of I minus 1. So using the same formula, we do the calculation for all of these, and our table is full. Okay, and these arrows are basically nothing but your, these values are nothing but your, the numbers are the length of the longest common subsequence, and the arrows basically tell you where the answer came from. So there are three arrows you see. One is up, one is left, and one is diagonal. So if you look at the first page, up will be this box, left will be this box, and diagonal will be this box. Diagonal is I minus 1, j minus 1. Okay, that is this. So this will be diagonal one. If you are do if the answer comes from I j minus 1, then you're going left using the left arrow. If it comes from I minus 1j, you are using the top arrow. So basically, you don't store the arrows as such. You can just, let's say, put some numbers instead to so let's say diagonal is 0 value, going left is value 1, and going up is value 2. So based on that, you will then be able to find out, uh, like I told you yesterday, what we are right now finding in the table is the length of the longest common subsequence. But what is the longest common subsequence? For that only we are storing this arrows or these values in another table, which we will use to read the final or display the final common subsequence. So in the end, we'll go over this once we look at the code. In the end here, we write a recursive function so that we can print the actual longest common subsequence. So if you are getting the value from the diagonal box, then you call I minus 1, j minus 1, recursive function. Okay, we'll go over it again. And once you return from it, then you will print this, because you don't want the sequence to be printed in reverse order. So it will print it uh, the way we are doing it in from the last to the first, because we match the last one and then the first one. But we don't want it printed in the reverse order, so hum uska reverse kar rahe hain, and that will be done using the recursive function. So we'll see that in the presentation again. Okay, so what again, this the array that we basically calculate, Cij, is the length of the longest common subsequence. Okay, and like I told you, this arrow, the values come from either up or left or diagonal. Okay, so ij minus 1, I minus 1j, or I minus 1j minus 1. So based on that, you are actually putting a arrow. Arrow is nothing, you can just put some mathematical values and make another array to store these values, so that you can get the actual subsequence in the end. Okay, so this is the coding part of this algorithm. So what are you doing in this algo? You're just filling up a 2D matrix again of size m cross n. M is the length of x and y is n is the length of y. So you are essentially just calculating two, in a way, two 2D arrays of size m cross n. So your runtime will definitely, because you're just filling up this table and the last rightmost corner value is your final length. Okay, and then you might have to write a recursive function to print, which is you have to print the longest common subsequence, which will be a linear program. Okay, so what we are doing here is, first we are initializing all I0 and 0j to 0. If either of the lengths of the string is 0, then the values are 0. Then a simple double for loop goes from 1 to m and 1 to n. What does it do? It just follows the formula that we just now saw. If xi is equal to yj, then the value in Cij is this. And we store in Bij, this is the table that stores the answer where it came from, okay, which will help us retrieve the subsequence in the end. Else, out of the two, I minus 1j or and ij minus 1, whichever is maximum, we will store that, and based on that, we will put the arrow either up or left. And then we return your C as well as B in the end. Okay, so this is another example. It's a little longer example, and they have just merged the two tables here, the B table and the C table. So if you look at it, this answer to this problem is going to be here. Okay, so this arrow will help you trace where it came from. So the 4 answer, it came from this 4, because it shows arrow up. So if you look at it, here you have B and A, obviously they do not match. So the answer does not come from there. The answer comes from the 6 and the 6. A and A, this matches. So this is part of your subsequence. Okay. Now this shows the answer comes from the diagonal value, which is 3. And 3 shows it comes from up, so it's here. It again shows it comes from left, so I'm just circling based on the arrows that have been defined. Okay, doesn't let me use this. So this it the value 2 comes from 1, this one comes from here, and this is the base case. So this is what will help you trace the longest common subsequence. So when do we use the diagonal value? That is when we find a match, right? Rest is it is maximum of the two. So just see where the diagonal, let me just erase this and just mark the diagonal ones. Okay, so this is diagonal, this is the second, this is the third, and this is the fourth. So if you see, B and B matches. If you see C and C, this value that is circled, again B and B, and A and A. Okay, so BC BA is the longest common subsequence. So how will this be printed out? So again, that's what they have done. They've circled the path which generates this longest common subsequence, the path of the subproblems, which will actually lead you to the solution. So this is what will help you print. Okay. So the running time of this print is m plus n. It is not m into n, so it's obviously less than m cross n. Why it is m plus n? Because you are calling a recursive function that it might go, because we are doing I minus 1, j minus 1. So it is going through entire length of x and or y. So it will be m plus n. So if you look here, uh, let's do it. Okay. No, they have not done it like that. Okay, let me use the whiteboard, and first let me find the length. 7 and 6. Okay, 7, 6. Okay, I write it down here only, be easier. So print, first of all, you're calling the print on I7 and J6. Okay, I is not 0, J is not 0. What do we have in the location 7, 6? We have 4 and the arrow is going up. So that means there is a mismatch. Okay, if the arrow is going up, then we are calling I minus 1j, which will be 6, 6. Okay, then 6, 6, the at if you look at 6, 6, this is the red one, 4. It is going diagonally to 5, 5. Okay, so I'll just write it down here. It calls 6, 6, then it calls 5, 5 because it goes diagonally. So once it calls 5, 5, it is again going up. It will call 4, 5. So then it will call 4, 5. And you see the print is only there when you are calling the diagonal value. So we call diagonal at 6, 6. I'll underline that, and we called diagonal at After 4 5, we have 3 4, 3 4, and that is the diagonal value. Then 3 4, you go to 3 3, and you have 3 3. Then again diagonal 2 2. 2 2 is again diagonal. I'm just trying to follow the table. Then 2 1 and 1 0. Okay, these are the pairs, these are the values that will be called, and only when you call I minus 1, j minus 1, you have print. So once it returns, when you reach to 1 0, when either of the two, it will return to 2 1. 2 1 is not a diagonal value, so it returns to 2 2. It prints x2. What is your x2? X2 is b. So I just write it down. It prints b. Then it comes down to 3 3. I'm just returning back like this. So 3 3 is C, then 3 4, 3 4, and then 4 5. 4 5 is actually B, and the last one is 6 6, which is A. So this will, since it returns, that's why you get it in the correct order, B C B A, rather than getting it A B C D, because the print is after the return from the function. Okay, you can do the same. You can run this print on the example I did on paper. I did not get time to write it down, so you can see what print pairs are called and when it will print xi. After, you can just trace it back like we do for recursive functions. Okay, so this is the print, and this is your actual longest common subsequence. So these programs are not difficult. You just have to understand how your problem is broken down into sub problems, and if you find repetitive sub problems, then we store the values, which is called memoization. So basically you write down the values you got for the sub problems or the smaller problems, and then you use them as you solve the problem in a bottom up fashion. So you build the higher order values using these lower orders, and you reuse these lower order values mostly because there are common subproblems. Okay, so this is a combined, here what you see is a combined B table and C table. You can make it separately so that you can, but you can, if you just look at the table, you'll find the substring by finding all the diagonally all the elements where you are getting the value from the diagonal box. Okay, so question. No, okay, the question is diagonal like 6633 means it's not that diagonal where you have I and J matching. It is that box which tells you that the answer came from the previous, basically the diagonal to that box. Okay, so like here, when you look at this 4, it tells you the answer came from up here. Okay, that means when it's I j minus 1 or I minus 1 j, that means there is a mismatch, and your answer is either coming from this or this. If you see both of them are 4, the answer could have come from any of the two. Okay, so now here it happens to be the case that this diagonal value here is coming 6 6, so it need not be the actual matrix diagonal. So it's the, that means the value of this comes from the this element, which means that when you were comparing uh, x6 and y6, okay, if you go up and see what is x6 and y6, it is a and a, so there is a match. Okay, then again when you trace it up here, 4 and sorry 4 and this next circle 3, 4 and 5, so the when you see 4 here and 5 here, okay, b and b are matching. Okay, so this 4 and the value at 4 and 5 comes from the this part of the equation. So the previous two subproblems plus this match of b and b gives you the length 3 here. So when I say diagonal, it is not the pair 1 1 2 2 3 3 like we do for a matrix. Okay, so the when you see a diagonal arrow in the box, that means that there is a match, and now the subproblems that you have, they are these subproblems, ci minus 1 and cj minus 1. Okay, clear? Okay, so let's go here. So there is some you can we have to calculate every entry of cij. It depends on either I minus 1 j minus 1 or I minus 1 j or I j minus 1. So we can also, instead of storing another all these arrows in another b table, we can also modify our code so that we can do the printing or storing, let's say, in a simple array. So whenever we are using this equation, we can store that value of xi somewhere and then later use it to print. So we will just eliminate one more table and find the actual subsequence. Okay, so if we only need the length of the longest common subsequence, to we just need to calculate the C table. And like you saw, when we are calculating this box, we need 1 2 3 these boxes. So we don't need any previous boxes anywhere here. Okay, so if you want to really save on space, you can basically, after you have calculated this row and this row, when you have to calculate this row, you can basically override the previous spaces so that you don't have to use. We have to, okay, the question is, do we need to construct C array? The problem is finding the longest common subsequence. So if you have to give the length, you have to obviously construct the C array to give the length. So the problem has two aspects. One is the length. The longest common subsequence says what is the longest, which one is the longest common subsequence. So length is a factor, and you should be able to give the actual sequence. So it depends on the problem, but generally, for a general longest common subsequence, we have to give the length of what is the length of the longest common subsequence. Either you'll be asked that, or you'll be asked what is the longest common subsequence. So then you need to print it. Okay, so like if you, since you need only these 3 boxes, you can basically use your space in such a way that you at any point of time you're just using two rows, because that's all your dependency is. You will not be using, let's say if this is 4, if this is 4 5, you'll not be using 1 2 or even 2 3. What you will have dependency on the row 3 1 3 2 3 3 and 4 1 to 5. Okay, so that way you can also save space if you really have that crunch of space where you have to save on the space you are using. So the dependency is only to the previous row and the current row. So we can eliminate whatever we have calculated before that by after when we move on. Okay, but then you have to see how you're storing the longest common subsequence, the actual longest common subsequence, which you can print at the end. Again, depends on the requirement. So you can improve the code based on what is actually needed. Okay, so any questions on this? No questions. So I hope you did the matrix multiplication problem that I had given to Aman. Okay, so any questions? I will give you another problem to solve on your own so that you can just see, solve one on your own, and also try to run the print function on your problem to see whether you actually get the real subsequence, longest common subsequence printed at the end. Okay, so Aman, have you taken attendance?
Not yet, ma'am.
Lelo.
Should I?
Yeah, take it.
Done, ma'am.
Done. Okay. So any questions? Just you can also email me if you have any doubts. We'll see what we start with tomorrow, either another problem or the next topic. Okay. All right. Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.